Hey guys, my name's Sam Cheney and we are back with another episode of Inspection Insights where we cover different applications using Geomagic ControlX. Today on our agenda we are using CT scan data to inspect a automotive component. Now hopefully all of you have lived very healthy lives and you've never had to have a CT scan, but if you've ever broken a bone or been to hospital and got an X-ray, a CT is basically just an X-ray, well, multiple X-rays stacked on top of each other to create a 3D image rather than a 2D image that you've probably seen before. Now, why am I talking about medical stuff? Well, most people's first or really only idea about CT scanning is in the medical realm. However, you can also use it for part inspection, for general 3D scanning, for reverse engineering projects, all sorts of different things. Now, most people will typically use an ARM-based scanner or a handheld device like we've seen time and time again on previous episodes of the Inspection Insights series. However, you can use CT scanners as well. It all depends on the material. If it's very, very dense and hard to penetrate through, you may have to look at some higher frequency or change the resolution size or so on and so forth. But the benefits of CT scanning over something like handheld or ARM-based systems is it can reach areas that the other systems that I previously mentioned cannot. Now, the reason though, like an ARM-based system or a handheld system can't reach in those areas is because it's line of sight. If you can't see it, you can't scan it. With CT scanners, it doesn't matter if you can't see it, but with the naked eye, it will penetrate all the way through and give you much, much deeper scan data because, again, it's not limited to a line of sight camera-based system. It uses X-rays. The industry that we'll be focusing on today is automotive. However, I try and keep it general, so this should apply to a lot of different industries as well. As always, we're going to bring in our scan data, our measured data, and also our CAD, overlay the two, do an alignment, do a comparison where we get this lovely looking color map, and then do some more formal dimensions using geometric dimensioning and tolerancing. Finally, we'll finish it up with creating an inspection report, and then I will wrap everything up. For those of you who regularly tune in, you will know the next two slides, but for those new, this is a typical inspection workflow inside Geomagic ControlX. We import our CAD data. Now, if you have ControlX Professional, this can be native SolidWorks formats, native Inventor formats, all of the big CAD players, we can import their native files. If you have Essentials or Essentials Connect, you will have to convert it to a neutral format like an IGES, a STEP, a Parasolid, etc. We also bring in our scan data. Now, this is going to be called our measured data inside ControlX because it's what we're measuring. We then do an alignment. I've already done a whole episode on alignments, so I'm not going to focus on it too much today, but I will have to do an alignment. And then we move into building the inspection. We'll do comparisons. We'll take measurements. We'll do all sorts of things to generate analysis that we can then put in our report and save that report out as a PDF. Now, I mentioned different plans and for example the native CAD formats. Well, that's something that's only involved in Professional, but we do have 3 different plans for ControlX, so you only have to pay for what you need. Maybe you're just starting out, or you don't have a high volume of inspections, or the inspections you do have are fairly simple. Well, ControlX Essentials might be the right choice for you. It has a whole tool list of comprehensive tools to do all sorts of analysis, take dimensions and do comparisons. The only thing that it lacks is some of the more advanced comparison tools, as well as the ability to scan directly into the software. So if you have CT data, you have scan data, you'll have to import that into ControlX. Now, what if you really wanted to scan into ControlX? Well, we have a plan for that too. It's called Essentials Connect. It has all the same tools Essentials does, but now you can also scan directly into the software with your commercial scanner. And we work with all sorts of different scan equipment manufacturers, so chances are we do have a plugin developed for you if it's a commercial system. Finally, ControlX Professional. This is the Ferrari of our portfolio in terms of inspection. It has everything I've mentioned in Essentials, Essentials Connect, and on top of that, you have the ability to do multiple result inspections, do some more advanced comparisons like the airfoil analysis that I've already covered in a previous episode, as well as surface defect inspection and a few other tools not listed. Well, let's move over to ControlX and take a look at this part. And we have our scan data, or our measured data as it's referred to. And you can see there is a big difference with CT data versus some scan data. So the first thing you'll notice is this kind of grain direction. It almost looks like wood, where you've got the different kind of slices as the model has kind of X-rays have been taken in the Y direction and in the X direction as well. And then it's been knitted together. Now, medical CT data is actually HIPAA protected, so the file format for that comes as a DICOM file. So if you are using those, you will have to convert the DICOM file to an STL file or to some other unprotected file. ControlX cannot import DICOM files, so that's just a bit of useful information to know. If it's just a part for engineering purposes, I don't believe that will come with those same HIPAA protections because it's not human anatomy. So you will still have to export from your CT data as an STL or a point cloud, and then come into the Quick Start and import the data here. Again, if we were scanning this with a handheld device or an ARM-based system, something like that, we'd be able to capture a lot of this outside. There might be some problem areas down under in this section over here, and that is because it is a line of sight based system, so being able to get into all these nooks and crannies can sometimes pose a bit of an issue. The real problem though is this internal geometry. Typically, if we're trying to scan, we're attacking the part from this angle, roughly, if this is about an inch, we can get about an inch in the depth. So the diameter of a hole in terms of penetration is about the same size as the diameter. So that means if we were using a vision-based system, we wouldn't be able to get this section over here. We probably wouldn't be able to get all of this lovely data that we have. So there are definitely some benefits to using CT data. Basically, you can reach areas that would otherwise be impossible. The trade-off for that, though, can sometimes be a bit of noise, a bit more scan data cleanup, and a very, very heavy mesh. So if I click on my measured data, you can see that we have 24 million triangles. Now that's definitely small enough for ControlX to deal with, depending on the size of your processing powers of your machine. But just to make things a little bit quicker, I'm going to come to my measured tab. And again, if I wanted to edit this, if I wanted to fill holes, I wanted to defeature an area or anything like that, maybe run the healing wizard, I could do all that from this. I want to keep the scan data as original as I can, but I do want to just knock down some of this data just to make it a little bit more easier to process for something like a webinar. So I'm going to come to my decimate tool, and this is going to reduce the model down. I can either specify the number of triangles or polyfaces that I'd like, or the percent. And 39.999, I mean, let's just call that 40%. So reducing it down to reducing 60% of this 24 million. I hit the check mark, and then I'm going to let it process, and it's going to selectively decimate the mesh. Now, what do I mean by selectively? It doesn't just flatly remove triangles. It will keep higher density of triangles in areas of more detail and reduce the triangle count, or make those triangles bigger in areas of lower detail. So a good example will be, these fins, they're large flat surfaces. They can be described with less triangles than something like these threads, for example. They will need higher resolution data over large flat areas. So we'll give it a second to decimate and jump back in when it is finished. And there we go. Through the magic of editing, just like that, we have decimated it down. But to be fully transparent, that probably took about 2 minutes. I just didn't want to have you guys wait while we were doing that. You can see it doesn't really look like this mesh has changed, but if I come on and turn the triangles on, you can see what I mean when I was talking about decimating and selectively keeping areas of high detail, like these threads. You can see the triangles are nice and small, and then lower detail areas, or lower featured areas, should I say, have larger triangles. So we've gone from 24 million to just under 10, and that for me is going to be much easier to work with, to generate things, and to just generally have a quicker experience. And again, for the purposes of this webinar, that is my ultimate goal, is to show you cool things quickly and so you understand them. If I was doing this for a more formal inspection, maybe I would just keep it at that 24, 25 million mark, and just, allow myself a little bit more time for things to process. Now we have our CAD model here as well. And one thing I love about CtrlX, especially when you're importing native CAD files, step files, is anywhere you hover over, it automatically knows the kind of geometry. So you can see if I hover over this cylinder, it comes up and my cursor tells me it's a cylinder. So same with planes over here. Now we do have an alignment, and you can see every single object that we've created has this little refresh icon, and that's because the model needs to be rebuilt. But before I do that, I will turn both the two on, and then we have our initial alignment, but I'm going to come to home and I'm going to give it another alignment as well. Now if I wanted to, I could do a best fit, I could do a datum alignment, whatever I'd like. And for the purposes of today's exercise, I'll do a datum alignment, because chances are this model is, or this part is, going to be constrained in a certain way, and I want to match the datums to do that. So we'll start with this bottom plane here, and I'm holding Shift so I can select those two faces as my first pair. Then I will select this cylinder, and then again holding Shift, select those two, make that my second pair. And now I just need to constrain. If you're ever confused, you can see this this view cube, there's this red arrow, and I can still move that. So this is my axis that needs to be constrained next, and I will just constrain it with one of these features here. Once I've got that, I hit my check mark, and then I have added my datum alignment. So the way I like to think about datum alignment is it's very similar to like a mates in a CAD system, where you've got to constrain all the different degrees of freedom. And there we go. We've done our datum alignment. I can turn that off so I can hide those annotations. And then I can start doing, the rest of my alignment. Now, as you can see, this model already has been completed. So all I actually have to do is just refresh, and it's going to recalculate all of this lovely work that I've already done. And then we will go through and review it. So it's going to start at the top, and it's going to rebuild the datum reference frame, then rebuild the 3D comparison. We've got some comparison points here. Oh, great, lovely. There we go. And just so there's not so much visual clutter, I'm going to go through it one at a time so I can turn off everything but my 3D comparison using these eye icons. And a quick tip for you, if you ever want to, if you've got to turn on lots of these things, if you just click and drag up, it's going to automatically, go through and turn things on or off very, very easily. So we have our 3D compare. We have set our color map to plus or minus 0.1, and this is in millimeters. But if you are American and you want to use inches, you can come to Menu, Preferences, and then change the measure length from millimeters to bald eagles per hamburger or whatever units you guys use. No, just kidding. Inches as well. If you change the input scanner length, the unit, this isn't going to change the working units that you're in inside ControlX. It's just going to change what units you import scan data into by default. But if you are importing it, there is also a button at the bottom saying use custom settings. So if once in a blue moon you have to use a different unit, you don't have to come to this menu before you import. You can just change it on the fly. So we have our 3D comparison. We've got our screenshot here. If we ever wanted to make this view kind of our main view, we can come to this button here, Apply Viewpoint, and then it's going to change our model window and bring it up to whatever this screenshot is. So a little quick tip for you as well. Another tip that sometimes people don't realize is ControlX can also calculate the volume and the center of mass and all sorts of different stuff on the CAD. So click our CAD, we come to our properties, and you can see here we can calculate the volume, the area, the mass center. We just have to hit the calc button and then it's going to calculate that. So if you didn't know that, now you do, and hopefully you've learned something. You can see also we can find the mass center in X, Y, and Z as well. Okay, so we've done our comparison, 3D compare. If I turn my measure data off, there we go. We also have done some comparison points. So we've gone around and essentially created some virtual probe points. And if I come to my comparison point, I can show you how that's set up. We just pick points over anywhere that we'd like, or if we want to create circular patterns or still any kind of pattern of these comparison points, we can. It's very similar to when we do our 3D compare. If I come back and edit this, and anywhere that we click on this in the second step, it's going to add a deviation callout as well. We've also done a 2D comparison, so we've taken a section down the center line, and then we have taken a cross section. And again, if I double click on this, I can open up the tool, hit next, and there we go. We've got a comparison in 2 dimensions. Now, if I want to, I can edit these whiskers. Ooh, we don't need to edit it by that much. Maybe let's just increase it to 1.5 or something. So you can still see some of the deviations. It's now just a bit more pronounced. There we go. Lovely. So all of these so far can be found on the Home tab. So 3D compare, 2D compare, and the comparison points. We do have some more comparison tools here, but we also have a whole compare tab. Gonna move this down a little bit. There we go. Where we can see, we can do virtual edge. So if you have, if you wanted to do, the theoretical sharp of this section over here, you'd pick the 2 corners, and then it would create a virtual edge deviation, geometry deviation, and then airfoil analysis, 2D twist, or deviation location. Those are all professional. Those are all tools inside ControlX Professional. Okay, so we've done our 2D compare. We then move on to our GD&T. So our actual dimensions, and we've got our first group. I'm just going to apply this viewpoint again. And you can see we've taken a few angles, we've taken a few radial dimensions and a linear dimension, just getting kind of overalls for this part in the first group. In the second group, we have some details over this section up here. Third group would help if I turned it on in terms of visibility. apply viewpoint. And then I'll just show the fourth and fifth group in the same. So there we go, press that. And the fifth group is actually, we created some datums. And again, I've covered this already, but if you come to the dimensions tab, most of these first few groups, group 1 through 4, are all linear, radial, angular dimensions over here. You can do all of these with one tool using the Smart Dimension tab, and that is just as simple as clicking and clicking on the CAD face, and then you've got an angle dimension. If I wanted to as well, I can change this preset to detailed or anything like that. And then in our fifth group, we've got our datums A, B, C, and then we've taken some flatness and some position, parallelism, and then that angular dimension as well. And I'll just remove that. So yeah, we've created our inspection report, or inspection template to do the last step, inspection report. We come to generate report, decide what we want to be included. Now, I don't really need an initial alignment. I really just care about that datum alignment. So I'm just going to remove that. And if I wanted to, move the comparison points down to the last section of my comparison section, I just press this button here. Can add in a title, edit any of these things, hit generate, and give it a second, and it's then going to populate our inspection report. So we have our CAD standard views, our measured standard views, the datum alignment, so you can see which datums have been used, 3D compare with the histogram and some standard deviations and some other calculated values. Our 2D compare. Now we've got a lot of deviation annotations here. So this is actually, below that is displayed in a table view as well. Comparison points as well. Same thing again, it's all displayed in a table as well as a visual to allow you to see the dimension and then also read it out and see some more details. Then all of our groups, so group 1 again comes with a table, 2, 3, 4, 5. You guys get the idea, I assume. So that's going to be it for this one. Hopefully you've learned a little bit. Feel free to reach out if you're interested in learning more about ControlX, or if there's something that you'd like to see on one of these episodes. I'd be happy to cover topics that people suggest. So yeah, have a good day, and I'll see you on the next one. Bye.